Hey everyone, welcome back to the JavaScript Dojo. I am Samir. Today we are not talking about animations, not about fancy UI. We are talking about protecting your users. Now imagine this. A user types a tiny script tag inside a comment box, and suddenly your app starts sending their cookies to an attacker. Scary, right? But it's real. And the good news? One security header can stop most of this. It's called Content Security Policy, CSP. In this video, I will explain CSP in simple language, show you a sample CSP meta tag, break down its syntax, and then we will implement it in a React plus Vite project, the static friendly way using a csp.json file. Let's get into it. CSP is like hiring a strict bouncer for your website. It tells the browser exactly which scripts, styles, images, fonts, iframes, and network calls are allowed. Anything that is not on the list, blocked. Even if a hacker manages to inject the code, the browser will say, "Sorry, you are not on the guest list." Let's step out of a React for a second and just look at what a content security policy actually looks like in plain HTML. Alright, this might look a little scary at first, but don't worry. Let's walk through it together and understand what each line is doing. Default SRC is self. This is the fallback rule. If you don't specify a rule for something, this applies. Self means only load from your own domain. Script SRC is self. Only run JavaScript files that come from your own domain. No inline script tags, no random CDNs. Style SRC is self, unsafe inline. Styles can load from your site. We are allowing unsafe inline because many apps inject styles dynamically. If you can avoid it, remove it. IMG SRC self, data, blob. Images can come from your domain or base64 or blob URLs. Font SRC self fonts.gstatic.com. Fonts from your domain or from Google Fonts. Connect SRC self api.example.com. This controls network requests like fetch. Only your own domain and your backend API are allowed. Frame ancestors none. This prevents your site from being embedded in an iframe. A defense against clickjacking. And the last one, base URI self. This stops attackers from changing your base URL using a base tag. So that's the syntax. Think of a CSP like a whitelist. You allow only what your app genuinely needs. Everything else is blocked. Now you might be thinking, this looks good, but I don't want to manually edit index.html file every time I build the project. Totally fair, especially in React plus Vite projects. So here's the plan. We will take this CSP, save it in a file called csp.json, and use a small script to inject it automatically during the build. But before we jump into the setup, let me explain something important. Why do we need different CSPs for dev and prod? In development, tools like Vite use hot module replacement or HMR. That means they sometimes inject code, use eval or inline scripts, which would be blocked by a strict CSP. So in dev, we relax the policy a bit, but in production, we lock things down. No unsafe inline, no unsafe eval, no wildcards like star, only what your app truly needs. Now, let's do it in React plus Vite. Let's create a project. Let's install packages. Packages are installed. Now let's run our project. The app runs at localhost 5173. We will add a CSP only at build time. not during dev. Now, let's add a csp.json file to manage policies per environment. In the root of your project, create csp.json. I am pasting snippet in it. Now let's understand this code. In development, we keep things relaxed. Vite's hot model replacement needs some flexibility, like allowing WebSockets and inline scripts, so a strict CSP would just break stuff. But in production, it's all about safety. We tighten the rules, block anything suspicious, and only allow what's truly needed. This helps against real-world attacks. And then there's the default. Think of it as a backup plan. Just in case the environment isn't set properly, it makes sure we are not running totally unprotected. Now, let's write a tiny build time injector script. Let's create a new file named inject.csp.cjs inside a scripts folder. If the folder doesn't exist yet, go ahead and create it. I'm pasting snippet in it. So this script will inject our CSP meta tag into the final HTML file after build time. Now let's wire it all up. Open your package.json file and update the build script to run our CSP injector after Vite finishes building. Let's understand what this line is doing. Vite build compiles our React code and generates the static files inside dist folder. Then we set node-env equal to prod as an environment variable. That value is used inside our inject.csp.cjs to decide which CSP config to pull from the csp.json file. This way we can have different CSPs for dev, prod, staging, etc. Now let's build and see it happen. Build is completed, dist folder is created. Let's open index.html file from the dist folder. Check this out. The meta tag is now inside our production HTML. No server needed, works perfectly on Netlify, Vercel, Firebase, GitHub pages, and anywhere. To properly test our CSP, I am adding an inline script in index.html. Open index.html file from root of your project. Add inline script tag inside it. Now let's build the project. Now let's preview the production version using npm run preview. Let's open console. Boom, it gets blocked. The browser refuses to run thanks to our CSP meta tag. You will see a message in the console that says refuse to execute inline script because it violates content security policy. This means our CSP is working exactly as intended. Even if a hacker gets into your DOM, the browser acts as your last line of defense. Now let's recap what we have learned. First, CSP is your browser-side firewall. Second, we learned the syntax, script src, style src, img src. Third, in React plus Vite, we keep dev relaxed and prod strict. And fourth, we used a csp.json plus build script to inject the CSP into static HTML. If you want a part 2 with CSP reporting hashes or nonces, drop a comment and let me know. Smash like if this helped. Subscribe to the JavaScript Dojo and I will see you in the next one. Code safe.